The term haptics refers to force feedback and the sense of touch. And for example, if you use a computer, often you interact with computer through a mouse, computer mouse. But just imagine that whatever you see inside the computer, if you were able to actually touch and feel. For example, if we take the case of training for epidural procedure, inserting needle into one's body, using a computer mouse, you cannot feel the insertion force, whereas through the use of a haptic device, holding a stylus, you can actually feel as you are inserting the needle into the flesh. So one can divide it into three areas. One is human haptics, and second is computer haptics, and third is machine haptics. There is a great synergy between haptics and robotics. We have designed and developed back-drivable robots, and you can feel the forces as robot being operated in an environment, and at the same time we have integrated haptic devices with robots, so we can create greater degree of telepresence and immersion for operators. The three areas are highly integrated, and you have to have understanding of all of the three areas, whether it is human haptics, machine haptics, or computer haptics. We have been designing and developing models, for example, what we call it modeling theme. And in the area of modeling, we are looking at soft tissue modeling, modeling of viscoelastic material, needle insertion modeling, and so on, which can be used both for biological and non-biological systems. And some of the application for these areas of haptics is virtual training. The research in the area of robotics within our center focuses on a couple of areas. One is industrial robots, whether they are design and development of new controllers for industrial robots or for the next generation of industrial robots, such as parallel kinematics, and or being in mobile platforms. In particular, our research in the area of mobile platform has been on systems where it can climb staircase, it can go under vehicle, it can pull large loads, and it can be haptically teleoperated and be tele-manipulated. And this has a lot of application both for defense, law enforcement, and manufacturing. A lot of research internationally, they've been focusing on single-point haptics, and one of our major focus has been on development of multipoint haptics. And in particular, we have designed and developed a system which focuses around the concept of multipoint haptics, because when we interact with objects, we normally use more than a single point. We want to grasp, turn, twist objects, whether it is a biological objects or metallic or synthetic, and so on. Therefore, our area of research has been focusing how we can increase this force reflection and fidelity, and also telepresence in the area of haptics. We have applied haptics at the macro level, meaning that we have integrated a haptic device with a robot for teleoperation, telepresence. But we see another area which is equally important, and especially in future becomes very important, is where haptic devices, they are integrated to atomic force microscopes, so we can achieve micro manipulation and nano manipulation. And so whatever atomic force microscope can see, we can use a haptic device to manipulate, touch and feel what AFM can see. It is possible in future through the use of this technology to bring microparticles together and manipulate and build new devices, new drugs, and perhaps one day to create patient-specific medication through this technology once it is fully automated, and perhaps having factories at micro nano level producing these kind of items.